My name is Roberto and our team is made up of Jorge, Jessica, Mauricio and Kareli. In the video we will explain some problems that we saw during the semester on the topics of law of cosines and law of sines.
Hey, I'm Jorge Alvarez and I'm going to explain the topic of law of sines or science law. I think it's basically the same. So I'm going to explain three general characteristics of this topic. I'm going to explain what is the law of sines, some of the history of this law through the time, and finally some of the applications that it has nowadays. So I'm going to start. I'm going to start explaining what does the law of sines say. The law of sines is the relationship between the sides and angles of non-right triangles. So it basically states that the radio of the length of one side of a triangle to the sine of the angle opposite that side is the same for all sides and angles in a given triangle. So now I'm going to start telling some of the history of the law of sines. It all begins with the astronomer and mathematician Al-Battani, who generalized the Euclid's result in a spherical geometry at the beginning of 10th century, which allowed the calculations of the angular distance between the Sun and the Earth to be made. The first trigonometric table for sine and cosine functions were discovered in this period. This allowed the mathematician Jiyad al-Kashi of the Samarkand school to formulate the theorem of the law of sines in a form usable for triangulations during the 15th century. And now we have Francois Viet, who made it known in the West since he rediscovered the law on his own. And now with this we finish the history of the law of sines, and I'm going to start explaining some of the applications. And here we have two very common applications for the law of sines. It has an application together with the law of cosines for problems of the angles of orientation for an airplane on the wind, and also if from a lighthouse we want to know the distance between two boats that are seen on the distance, we can use the law of sines. And with this, I finish my presentation, and my team is going to keep explaining some problems of law of sines and law of cosines. Thank you.
Hi, my name is Ramon. I want to tell you about the Pythagorean theorem, or more specifically, I want to tell you about the cosine theorem, or also known as the law of cosine. This theorem relates one side of any triangle to the other two sides, and the cosine of the angle formed by these two sides. The law of cosine is used to find the missing part of an oblique triangle when the measures of two sides and the measure of the angle included are known, or the measure of all of these three sides are known. The cosine theorem established that c squared equal to a squared plus b squared minus 2 cosine c. This is equal, or this resembles, the Pythagorean theorem, except that for the third term, that is c, and if c is a right angle, the third term is equal to 0, because the cosine of 90 degrees is 0, and the Pythagorean theorem is obtained. The law of cosines can also be started as these two formulas can be established to, that is, b squared equal to a squared plus c squared minus 2ac cosine b. This b, or this a, is the angle of the side b, or the side a, that you can or a squared equal to b squared plus c squared minus 2 bc cosine a. And two are these two formulas are the you can establish the cosine term by these two other formulas.
Hi, my name is Jessica Kareli Garcia Alvarado. I'm currently studying a mechatronic degree, and today I will be talking about the law of sines. To help with the presentation, we will be using to follow an exercise and an example. We have a triangle for which we know one angle and side measure, but we are still missing the rest of them. The first step, we should always take a naming both the angles and side. This will be angle E, angle B, angle C. In a way that we can easily say, if this angle E, then opposite will be angle B, to which the opposite will be called an angle C. Um, with this information beforehand, we can start working. We have all data for the air pair. Since we know both angle and side measure, so we are going to use it to find the angle B pair since we already know the side measurements with the help of the following formula. The product of both sides divided by the product of the both side measurements. We'll start by replacing angle E with the 100 degrees and side E with 17, as well on the B side with 13, and the B angle with an X. Since is the measures we want to find. Then we clear up below for B putting its side on the other pair of equation and changing in this process. Sin is y dividing now this multiplying, which will leave the B sign alone and sign alone, yeah, but clearly signs a reverse on multiplying but rest of equation. So now um so we know proceed to calculation for B and we go up the with 48 degree, 51 minutes and 30.99 seconds on the resonance. Now, now we can both the A and B pairs and we are only missing to C. The C angle has a value of 180, so when subscribe the other two we already have. 100 less 48 degree 51 minutes and 30.99 seconds and the gives our result on 31 degree 8 minutes and 29 that's 01 seconds. Lastly we take a side and we divide it by its own sign, which is equal to C size divided by the its own signs as well. We replace the according measurements and values, yeah. We already have A side is 17, is and E sign 100, C sign 31 minutes 8 I'm sorry, 31 degree, 8 minutes, and 39.01 seconds. So that we end up with the following equation. 17 divided by the product of sines times sine, which equal 8.92 meters, and giving the answer for all measurements and ballots needed. Thank you.
Hello, my name is Mauricio and I am going to explain an example about the law of cosines. Law of cosines. Example. Step 1. Place the names of the angles A, B, C always in capital letters. A, B, and C. Step 2. Indicate the corresponding lowercase letter on each side. A, B, and C. Step 3. Of the three formulas corresponding to this law, choose the one that helps us find the missing sides 1, 2, 3. In this case, the formula we use is the first. Step 4. Substitute the data in the formula and carry out all the affected operations.
In conclusion, on we have done this task, we know better when to use law, as the law of cosine is used when we know more sides of the figure than its internal angles, and the law of sines is used when we know more internal angles than sides of the triangle.